So in our previous session, we have started with the discussion of representation of numbers. Okay, in Verilog, how to represent binary numbers and how to represent negative numbers, and what are the special characters we have. And we have also seen unsized numbers, sized numbers, how to represent different hexadecimal numbers or octal numbers, right? So we have seen the number specifications, everything we have seen, like we have seen the basic constructs. Okay, now so in this particular session, we'll start with the topic called strings. Okay, I hope you are already aware of this particular topic, which is known as string. Okay, string is nothing but a sequence of characters that are enclosed by the double quote. Okay, so strings are a collection of characters. 1 minute, let me. So strings are nothing but the collection of pointers, collection of characters which are enclosed in a double quotes. Okay, so anything which is written inside this double quote is a string. Okay, so here in this particular example, hello Verilog world. Okay, so this is a particular string, and here a divided by b, it is written inside the double quote, so it will become a string. Okay, string is nothing but a sequence of characters that are enclosed by the double quotes, and the restriction on a string is that it must be contained on a single line, that is without a carriage written, and it cannot be on multiple lines, and strings are treated as a sequence of 1 byte ASCII values. So these are treated as sequence of 1 byte ASCII values. So each letter, each character has 8 bits. Okay, 8-bit ASCII value, 8-bit ASCII value. Okay, so even the space is also being counted. Okay, so each character has 8-bit ASCII value. Let's say suppose if you have good. Okay, so this is a particular string, so how many bits it will take? So how many bits?
52.
Right, so 8 into 4, which is equal to total 32 bits this particular string is going to occupy. Okay, so that is how the strings work. Next is identifiers and keywords. That carries written everything we will see in the upcoming sessions. Okay, yeah. Now let's see about this identifiers and keywords. So keywords are special identifiers reserved to define the language construct. Okay, so keywords are special identifiers. Keywords we cannot use as an identifier. Let's say suppose reg is our keyword, and module is one more keyword, end module. Okay, or wire, input, output. Okay, so these are all our keywords. Okay, so this should not be used when you are declaring your variable names. So these keywords cannot be used as your variable names. Okay, so these are special identifiers reserved to define the language constructs, and keywords here are in lowercase. Okay, here the keywords are in lowercase, not in uppercase, whereas identifiers are the names given to the objects so that they can be referenced in the design. Okay, identifiers are made up of alphanumeric characters, underscore, and a dollar sign, and are case sensitive. Okay, so Verilog is a case sensitive language. Please do remember this. Verilog is a case sensitive language. That is, if you declare any variable in the small case, you should use that particular variable in the small case only. Okay, you cannot use in the uppercase. For example, here if you have declared a variable reg small, in small letters you are writing value. Okay, and somewhere in your code you cannot write capital letters value. Okay, because Verilog is a case sensitive language, you should be careful. Okay, if you declare something in small letters, it should be used in the small letters only, you cannot use capital letters. Whereas in the case of VHDL, this in this programming language, it is case insensitive. Okay, so if you can declare the particular variable in small letters, and you can use it in capital letters, because VHDL is a insensitive and Verilog is a case sensitive language, so you should be careful in this. So is it clear? And identifiers start with a alphabetic character or an underscore. Okay, you can start an identifier with an alphabetic character or underscore, and they cannot start with a number or dollar sign. This you should remember. So if you declare any particular identifier with dollar sign, it will become a actually the variables or the keywords which are starting with dollar sign are system directives. Okay, let's say suppose you have dollar display, okay, dollar monitor we have. So all this will start with dollar symbol. Okay, this, so that's why you should not use any identifier with the dollar sign starting at the first position. Okay, or you cannot use a number. Okay, you cannot use a number at the starting position, and you cannot use dollar symbol at the starting position. So these are some of the rules which you should remember. And for example, here you can use reg. Reg is a keyword. In this particular case, reg is a keyword, and value, it is an identifier. Okay, value is an identifier. Okay, so this is how you should declare any particular identifier. Let's say suppose if you write reg dollar value. When you're declaring any particular identifier, you cannot start the particular starting place with a special character, that is dollar. Okay, or you cannot also use hash like this. You cannot use special characters, and you cannot use numbers when you're declaring any identifiers. Not only these variables, when you are writing your module name also, module, if you say 1 bit full adder, you cannot write 1 bit. While when we are declaring a module name, okay, module followed by the name is nothing but the identifier. So here we cannot use like this 1 bit full adder. Okay, so you cannot use number at the starting position because it is an identifier, and you should abide by the rules of an identifier. Okay, so this is the rules which you should follow when declaring in identifiers and when you are using a keyword. Okay, so that was about identifiers and keywords in Verilog. Next comes the data types in Verilog. Okay, so let's see what are all the data types. So before going to data types, we will see the value set. Okay, so Verilog uses a 4-valued logic system to represent signals and variables. Okay, so there are basically 4 type of values. One is 0, and another is 1, x, and z. Okay, regarding this z and x we have discussed in our previous session. Do you remember what is mean by z? Can anyone tell me?
High impedance.
Okay, so what actually it indicates, like what it will tell? If something is unconnected, you can represent that particular state by this high impedance z. Okay, and x is for unknown. Okay, we cannot tell whether it is 0 or whether it is equal to 1. Okay, now, so 0 we all know, and logic 0 is for false condition or low voltage. In Verilog, this particular logic 0 is for false condition or low voltage, and 1 is for true condition or high voltage. Okay, now, so in Verilog, 0 is for false and 1 is for true, and x is for unknown, and z is for high impedance. Okay, do you remember this? Now, let us start the discussion of nets. Okay, so basically these nets are used to represent physical connection between the circuit components like wires. So nets continuously drive their values from the drivers. Okay, cannot store values independently. So the nets are not used to store any value. With the help of nets, we cannot store any value. Nets are not used to store any value. These nets are only used to drive the value from one component to another component. Let's say if we have component 1, okay, or your any design component 1 and component 2. Okay, and if you want to connect these two components, you are going to use this net data type. Okay, in net also we have several data types, wire, WAN, everything we will see one by one. So if you want to connect these two components, okay, you are going to use this net data type. This net data type, with the help of this net data type, you're not going to store any value. Okay, you are just going to drive the value. Okay, so in this particular example, component 1 is driving the value into this net, and the value is being passing from the component 1 via this net, and it is reaching the component 2. Okay, so that is how net has drivers. Okay, so this here component 1 and component 2 are our drivers. These are driving the value. Okay, these are driving the value to the net. Okay, so is it clear? The net data type, is it clear? Net data types are not used to store, yeah, net data types are not used to store any value. These are basically used to drive the value. Okay, next, and their value changes immediately when the driving source changes. Okay, so if instead of component 1 we have component 3, the value changes inside the net. Okay, so the value which is driven by the net will be changed according to the driver, okay, which is present. And in net we have several other nets are classified into several data types. First one is wire, followed by WAN, followed by war, and supply 0 and supply 1. Okay, let's see one by one what are this. And okay, first one is wire. Okay, basically this wire is used to connect two components. Okay, wire is going to connect, or it is a basic net data type used to connect two components. Okay, here wire is a data type. Wire is a data type. Okay, you can declare any variables with this particular data type. Here in this particular example, within a module we have declared three variables a, b, c of which data type? Wire data type. Okay, now so you are going to use the keyword. So what is the keyword you are going to use? You are going to use the keyword wire. Okay, wire is the keyword used to declare any wire data type. Okay, do remember the keyword wire. Keyword small letters, not capital letters. Okay, small letters, small wire. Okay, wire is a data type which is used to create a wire data type. Okay, so here you have declared three variables of wire data type, and if you want to drive any value to this wire data type, you are going to use this keyword which is known as assign. Okay, you are not storing any value inside a, you are going to drive the value. Okay, so you are going to use this keyword which is known as assign. A is equal to 1, assign b is equal to 0, and assign c is equal to a and b. Regarding this assign keyword, we will discuss in detail in the data flow modeling. Okay, for now remember or see it as a just a keyword. Okay, assign is also a keyword. Okay, so this keyword you should use with this particular wire to drive the value. Okay, so what value has been driven by this a? 1 has been driven. Okay, we are not storing anything inside this a, we are driving the value. Let's clear the variables. And how we are going to drive the values? We are going to use the keyword assign. Okay, about this assign we are going to discuss in the data flow modeling. How this works, everything we will discuss there. Okay, now, and the default value, yeah, let's say suppose we have declared any wire, let's say x wire, let's say wire m. Okay, so we haven't driven any value to this wire. Then what is the default value? Can anyone guess?
Z.
Yes. So default value is high impedance. Can you guess why it is high impedance?
Because it is not connected by someone. Not nothing is driving it.
Yes, yes. So the basic definition of high impedance also we have discussed it. So that's why here the wire, the default value of wire is high impedance. So you can note it down. It's a very important interview point of question also. So the default value of wire is equal to high impedance. Okay, you can note it down. Default value of wire is equal to high impedance. So if nothing is driven to this wire, the default value of this wire will be equal to high impedance, and if it is driven by some value, the value will be stored in the value will be driven by that particular wire. Okay, and next come WAN. Okay, now before discussing about this WAN data type, let's say if we have two components a and another component b. Okay, and these are driving the values into a single wire. Okay, so we have two components, A and B. Okay, so these are driving some value to the same excuse me, to the same wire. Okay, so these two components are driving some value to the same component, uh, or same wire. Okay, so what will be the value of this wire? Can anyone guess?
A and B.
No, no, no. Here, let's take, let us declare wire A. Okay, let's assign A is equal to 0, and let's write assign A is equal to 1. Okay, now if we display the value of A, what will be the value of A?
1.
One.
One.
Okay, others the same multiple values to a same wire, we will get unknown. Okay, remember this, if we drive multiple values to a same wire, we will get unknown. Okay, we will get an unknown. Okay, so this you should remember. If we, in the case of wire, if we drive multiple values to a same wire, okay, then we will get unknown. Okay, so to avoid this limitation, we can use a WAN data type. We can use a WAN data type, which is also a net data type only. But here, in the case of WAN data type, if we declare any variable with this keyword, particular keyword WAN, and if we assign, here you can see assign A is equal to 1 tick binary 1 and assign A is equal to 1 tick binary 0. So what may be the output if we display A? If we display A, then what may be the output we will get? We have written assign A is equal to 1 tick binary 1, assign A is equal to 1 tick binary 0. So if we display A, the name itself indicates it's an AND operation. So AND operation will be performed between 1 and 0, and the result will be driven into this particular WAN. Okay, so if multiple values are being driven into this particular WAN data type or WAN variable, okay, then what happens? The output will be AND operation of these two values. Okay, and next is war. That means what will happen here in the case of war? What is going to happen? So in the case of war, what is going to happen? In the name only we have what is,
Or operation.
yes. So the result will be OR operation of the two values. Okay. Yes. So here, if we drive 0 and 1, so 0 or with 1 is nothing but 1. Okay. So 1 will be driven. Okay. So I hope why we are going to use WAND and WAR. I hope it is clear. Okay. So what is the limitation of wire and what is advantage of WAND and WAR? Okay. I hope it is clear. Next is supply 0 and supply 1. Okay. So basically, these are used to give a constant logic 0 or constant logic 1. If you give this keyword supply 0, then it is given to a logic 0, and if you use this keyword supply 1, it is given to logic 1. So this is basically logic 1, and this is basically logic 0. Here in this particular example, you have used the keyword supply 0 followed by GND. Okay, so this GND variable will be having a value of 0 only, because you are using this data type supply 0. And if you use this supply 1 with this particular variable, this VCC will have the value of 1. And in this particular, you can see we are doing AND operation. Okay, VCC and with not of ground. Okay, these operators we will discuss in detail in upcoming slides. Don't worry about the symbols. Okay, so VCC and of not of ground. VCC is 1 and operation with not of ground. GND is 0, that is not of 0 is 1. Okay, 1 and 1 will get 1. So like this, if you mention any variables with this particular keywords supply 0 and supply 0 is for logic 0 and supply 1 is for logic 1. Is it clear?
It should not be X, right? Because it's constantly updated. So I think it should be 0.
Assign A is equal to 0.
Yeah, then I did assign A equal to 1.
Here there is no time delay. So that is what I said, right? So about this assign keyword we will discuss. So these two assigned words will be running parallelly. Okay.
So at
So
the same timestamp, they will run
yes,
together.
yes. Okay.
But
This we
if
will.
I
Hmm.
include a delay between them, then it will be 1.
Yes. If we include delay #5, some delay construct if we use, then the last updated value will be shown.
Okay, thank you.
Yeah. So about this assign keyword, the parallel execution, that is the concurrent execution, everything we will discuss in the DFM. Okay. Yeah. Now, when we declare any variable as var, let's say var x, okay. So by default, if we have not given any value to this x, so what is the default value which we have seen? What is the default value?
Z.
Z.
High impedance or z. Okay. But in the case of try 0, the default value will be equal to 0 if it is not driven. Okay. So if you use a keyword try 0 data type with a variable try 0 a, then the default value will be equal to 0. So by default, if we haven't driven any value to this particular variable, the default value will be equal to 0, since we have declared that data type as try 0. And if we have declared try 1 b, then by default the value will be equal to 1 if we haven't driven one. Okay. So this is how try 0 and try 1 works. The default value will not be equal to z. The default value equal to 0 if we use try 0, and if we use try 1, the default value will be equal to 1. Okay. Is it clear?
Yes, sir.
Now we will discuss about register data types. Okay. So basically these registers are used to store the values. Okay. So basically if you want to store any value, you should use this keyword. You should use this data types which are known as registers. Okay. So basically these are used to store the data. Okay. So unlike nets, registers retain their value until explicitly changed. Okay. So until these are changed, so they hold the value. Okay. And these are used for modeling sequential elements, temporary storage, and variables in the procedural blocks, always or initial, that we will see in the BFM, that is behavioral flow of model. Okay. So basically if you want to store any value or any number or anything, you can use this particular register. So the keyword for declaring this data type reg is small reg. Okay. So this is the keyword you are going to use for declaring a register data type. Okay. And it is most commonly used for procedural modeling, that we will see in the behavioral style of modeling, where how it is used. Okay. So the keyword, do remember the keyword, it is small reg. Okay. So if you declare any data type, any variable with this particular data type small reg, that variable will be of registered data type. Okay. Let's say suppose if you have declared reg a, and you can store any value, a is equal to 1 tick binary 1, or a will be equal to 1 tick binary 0. Okay. So this is how you're gonna you can store the value. And can anyone tell me what is the default value of this particular reg? What is the default value of this particular a if you have declared?
Unknown.
Yes. Okay. So the default value of registered data type is, the default value of reg data type will be equal to unknown, whereas the default value of wired data type will be equal to high impedance. So these are the two important points to be remembered. You can store the values like this. Now, if you, let's say if you have declared wire b, then what is the size of this particular variable b? How many bits can we store in this particular b? We have written wire b, then how many bits can this particular variable b can drive? We cannot store in wire, right? How many bits it can drive? Any answer? Any guess?
32 bits.
Okay. Others? Only one answer I've got. Only two answers I've got. Okay. Only three answers. So if we haven't explicitly declared the size, then it will only store one bit. Okay, it can only store one bit, either 0 or either 1. Okay, sorry, wire cannot store that. It can only drive the one bit. If you use the reg a, then here it can store only one bit, either 0 or either 1. Here it can drive either one bit, only one bit, that is either 0 or 1. If you declare any variable with reg data type, then it can only store either one bit, either 0 or either 1. That's it. Okay, you haven't given any size here, reg a. So reg by default it can store only one bit. Okay, is it clear?
Yes, sir.
And if we use integer, let's say integer a, then what is the size?
32 bits.
Yes, then here
32 bits.
it will be equal to 32 bits. Then you can say here it is equal to 32 bits. Okay, but here it cannot be, it is only of one bit. Okay, so that was about reg, and here it's an example of a clock generation that we will see later. uh, I should explain first initial, begin, end block, everything, and after that I will show you. So that was about the net data types and reg data types in Verilog. So we have started with our data types, and we have seen the value set, and we have also seen the default values and the different types of net data types, wire data types, everything we have seen, and the behavior also we have seen. And yeah, so if you're having any doubts or queries, you can ask me, or else we can end this session.